Bar graphs are as simple, if not simpler, than pie charts, and as we're going to see, they work a lot better. They're much better graphs. And again, I don't have to explain to you that when you have a bar graph like this one, what that means is that each one of those graphs has the corresponding frequency. So we have the four values A, B, C, D, and this time I've listed them from the bottom to the top. It doesn't really matter which way you do it. For now, let's assume this is a nominal variable. And so A, for instance, would have 12%. It's the same values as before. So A would have 12% of the observations, B 25%, C 33%, and D 30%. Okay. Now, this is also a very simple graph. It is also very well known. It is also very attractive. You can make it colorful, and we're going to see in a minute or soon what kind of variants can be made, and so on and so on. And in fact, there are many good variants that can be made to make these bar graphs very attractive, very interesting, very nice to look at, and very full of information. And they're technically stronger. For instance, as I said, in the graph, the pie charts can only be used for nominal data, and we've used the bar graph for nominal data as well. But remember, nominal data don't have a natural order. That A, B, C, D is an alphabetical order. That doesn't mean anything. So one of the things we can do, for instance, we can rearrange those four values, not according to alphabetical order, but according to their order of frequency. So for instance, I can make the same graph look like this. So I'm going to put C on top. That was the biggest slice, if you remember, and so the biggest bar, and I put that one on top, and then D, which was the second one, and then B, and then A. Okay, so in this case, in this way, I can actually easily compare the different values, and I know exactly by comparing them along the percentage line which one is the biggest one, which one is the second biggest one, and so on, and make all kinds of very useful comparisons. Now, there are other advantages to bar charts. For instance, they're good for all levels of measurement. We've already seen that they're good for nominal, but they can be used for ordinal variables or for numerical variables as well. In fact, there's a bit of a convention that if we have a nominal variable and we want to make a bar chart for it, then we're going to use horizontal bars like the ones I've shown you up to now. And again, as I said, it may be a better idea to actually put them in increasing or decreasing order of frequency. But if we're going to use an ordered variable, meaning ordinal or interval or ratio, we're going to draw those bars vertically. Now, there is still, so this is another way in which bar graphs can be very flexible. Okay, there are other advantages still. A bar graph can differentiate between discrete and continuous data. For instance, with the same data as before, what we've seen here was the case where the four values A, B, C, D were in fact discrete values, so they were separated. And I indicated that by drawing those bars with a big gap in between any two of those bars. But let's say that those A, B, C, and D were four groups coming from a continuous variable. Let's say A would be young people, B adults, C mature, and D seniors. Okay, then I'm dealing with a continuous variable, and what I can do is I can represent the same data by making those bars adjacent to each other. In this way, what happens is that the continuity of the data shows up quite clearly even in the shape of the graph itself. But that's not all. We have other advantages. For instance, with bar graphs, what we can do is we can overlap several data sets. For instance, here we have a single set of data corresponding to the values A, B, C, D. But what if we had collected data from a different group, from a different sample, and we wanted to compare them? Well, that's easy. All we have to do is just do two sets of bars with different colors, and that's going to allow us to compare the distribution and the percentages for each of those values. So as you can see, very flexible, lots of different things that we can do, very solid and very much related to the statistical meaning behind it. So in my opinion, much better than pie charts. We're going to look at one more application and then a couple of things that can go wrong with bar graphs, because yes, things can go wrong with bar graphs too.